okay? But there's a separate state in the task struct, okay? This thing is called an exit state that distinguishes between these two, this one being called exit zombie, and this one being called exit dead. Okay? So this is exit zombie and this is exit dead. Okay, so all I'm just saying is that this is the right mental model. You can think about how processes run. The actual details of how this information is tracked may be a little bit different depending on the operating system implementation. Yes?
Does that mean that structure is going to remove
No, this is just to denote that it's no longer runnable, but it's a separate exit state. But once you're no longer need to be zombie, then you're waiting on the task structure.
Yeah, which means there are technically one state and then otherwise there's no state or
I see your question. Okay. So the question is, so if you're in a dead state, you can clean it up, right? So why do I need to keep track of the dead state? Where's that dead state stored? And the answer is, you're right, okay? But what ends up happening is the actual cleanup, you could clean it up immediately, but the way Linux does it essentially is it says, okay, it keeps track of, does this thing need to stay around? And then it says, this doesn't need to stay around anymore. And so something then will eventually go look at all the things that don't need to stay around anymore and then actually does the cleanup. So it's a little decoupled in that. Okay. All right. Now let me just say something about these three things just so it's clear. Okay, task stop. First approximation, that's sig stop. You send a signal, right, which is a sig stop signal, then that puts you in the task stop state. Okay. These two are the difference between the two is whether or not if I'm in the block state, okay, this is a little caveat, okay, whether or not if I'm in the block state, if the task receives a signal, should I wake the task up? Okay? That is, if I'm in the block state and I receive a signal, should it stay here? Or should it go to here? Okay. Let me give you an example. You're waiting on keyboard input, right? Your browser's sitting there waiting on keyboard input, right? You send it a control C. Do you want the browser to continue waiting on keyboard input, or do you want it to immediately terminate or terminate as quickly as possible? You want it to terminate as quickly as possible, right? So that is a case where what ends up happening is that call, that read, which it knows is on this keyboard device, will be in a block state, in a task interruptible state, okay, so that you get that signal, yeah, okay, fine. Okay, I will interrupt the system call and I will become running. Okay. And just to be clear, okay, what actually happens is the system call is interrupted. Okay, interrupted meaning it doesn't finish. Okay, it sort of returns prematurely. Okay, and actually, if you check Arano, okay, what you'll see is the system call will have an error node corresponding to INTR. Okay, so it'll actually have a value which says this system call was interrupted prematurely. Okay, and so you could actually check, did the system call get interrupted prematurely, or did it actually complete? Right, and if the error value says it got interrupted prematurely, that means it got some signal, stopped doing what it was doing, blocked, right, eventually came runnable, right, running, basically returned from the signal, said, sorry, I got interrupted. Okay? But, okay, if on the other hand, I'm trying to access the disk, okay, waiting for I/O from the disk, okay, which has a reasonably finite amount of time, right, should happen in a couple milliseconds at most, right, and it's probably going to set up a bunch of device states, say do a whole bunch of stuff, right? Wait for the I/O to complete. In that case, it's not some unknown amount of time, right? It's some finite amount of time, and I've got to set up a whole bunch of stuff. And then in that case, it's task uninterruptible. Okay, that is I'm no, you send me a signal, sorry, I'm not gonna pay attention until I'm actually done doing that, right? And then I'll become runnable, then I become running, and I'll take care of the system. Okay? So just keep in mind two distinctions. Okay, some system calls are interruptible, some may not be. Yes?
What's the difference between task stop and task interrupted?
If it's task. So task stop is just another state used to keep track of say stop. That's it. And it's just, okay, you have a stop. It only says I'm going to put you in a different state than this case. And if you look at the underlying implementation, it looks a little bit different. I mean, could you have put them all together? Yeah, I could have, but they chose to make it simple. Okay, yes. Does each system call manually set error? And the answer is first approximation, yes. Okay. So if you look at your system call, right? For example, the one that you're implementing, right? If you don't return successfully, you should return an error condition, right? You should return minus efault, minus e, inval, right? Whatever the case is, right? We showed you some before, right? And then as you're returning, right, in user space, right, you typically it's some library, right, in between your program called the library function, which called the system call, right? So you return to the library function and call the system call. That library function will read the return value from the actual kernel thing, and if it's negative, will set errno with the negative of that value, and then we'll set the return value to -1, and then that's what actually you get back from the library function called system. I see. So remember, interrupted here. Now I'm referring to a system call that's interrupted. What I mean by system call that's interrupted means it was the process to call that was blocked. If the process to call that was blocked, it's not running. It's not executing any code, right? So you kind of imagine how this works in terms of your actual system call, right? So you have some syscall, right? Right? And eventually that will go into the kernel, right, which calls the syscall handler. And eventually that looks up the system call table, right, finds some function, and your function is going to be syscall, define in Linux, right? Say 2 arguments, and then a bunch of stuff, right, for example, right? And then you've got a bunch of code in here doing stuff, right? And at some point in the code in here, you're going to do something in the case of a system call that was blocked, which will execute some code, right? Which then you'll change the state to, task interruptible, right? And we'll eventually call schedule. There'll be some code in here that does that, right? And then you can imagine that when your system call returns, right, from calling whatever functions it did, your system call, if it is a system call that can be interrupted, should check, well, whatever I was waiting for, did it actually happen? Or did I get interrupted? Right? And if you got interrupted, then it should say, oh, I got interrupted, I should return -e intern, say I got interrupted, and then stick those stuff down there. And if it didn't get interrupted, then you'll proceed on your normal way, and then you'll do whatever you did, and eventually you return, say, 0 if it's succeeded, or something else happened, return default, right? So again, it's just where in the code did it happen, right? And if it happened in this portion of code, then you return the appropriate error.